A drug is injected into a patient's bloodstream through her right arm. The drug concentration, which is given here in milligrams per cubic centimeter, and then it is represented by C of T. Okay, so the drug concentration in the bloodstream of the left arm T hours after the injection is given by this formula over here, or let's say by this function, concentration function, which is 0.14 times T, and underneath that we have T square plus 1. So this is the concentration function given after the injection, right? And then here is the question you need to solve. You need to find what is C prime of 0.5, and then also try to see if you can find C prime of 3, and then try to see the whatever result you get it, and then interpret that what is the result mean. Okay, so let's try to work on this problem. So since the question is actually pretty straightforward, we need to find the C prime at 0.5. So let's just try to first find what is C prime of T. That means find the rate of change of the concentration function, or let's say find the derivative of the concentration function. So how do you find the derivative? How do you find C prime of T in this particular case? Since this is given into the cosine form, right, a function at the numerator, a function at the denominator, so we need to use the cosine rule, right? So how do we use then the cosine rule? We write down the function of the bottom as it is, which is T square plus 1, but multiply that by the derivative of the top. And what is the derivative of 0.14 times T? If you differentiate that with respect to T, we get 0.14 times derivative of the T with respect to T, which is 1. So just 0.14, right, is the derivative of the top. And then minus, now we need to write down the function of the top as it is, so 0.14 times T, and multiply by the derivative of the bottom. And what is the derivative of T square plus 1? Derivative of T square is 2T, derivative of 1 is 0, so just 2T, right, is the derivative of the bottom function. And then everything underneath that is the square of the denominator. And by the way, this is from the quotient rule, right? So if you have f over g, then the derivative of that will be g f prime minus f g prime over square of the g. And then that's what exactly happening over here. I assume this is like your function f, this is like your function g, and then on that case you can clearly see this is your g f prime, and then minus f g prime, and then g square, right? So you can clearly see I apply the quotient rule here. So we have the C prime of T. So once you have the C prime of T, then finding the C prime of 0.5 is not a difficult job. Either you can actually first simplify the C prime of T and then actually evaluate at 0.5, or right over here also you can evaluate the C prime of 0.5. It's depend on your choice, but for at this moment I just want to actually simplify this further. Okay, so 0.14, distribute this over here, right? So and then we get 0.14 T square plus 0.14. When we distribute by 0.14 we get that, and then minus 2t times 0.14 t. When you multiply those together, right, so what do you get? You get 0.28 t, and everything underneath that will be square of t square plus 1. So now you can combine the like term. This is something over here, 0.14 times t times 2t will be 0.28 t square. So now when we combine the like term here, you can see the like term is given over here, and then when we combine that we get negative 0.14 t square, and then plus 0.14, and then everything underneath that will be square of t square plus 1. So this is just if you want to simplify this one, because the main job here is to find the C prime at 0.5, so which you could also do it over here with this expression, but since I simplified, let me use this and then try to evaluate C prime of 0.5. How do you find, if this is C prime of t, how do you find C prime of 0.5? We just need to replace t by 0.5, right? So let's do that, and then we get this as negative 0.14 times square of 0.5 plus 0.14, and everything underneath that will be square of the square of 0.5 plus 1. All right, and then you can use your calculator to see properly how much is that. And here I have one answer. This is approximately equal to 0.0672. That's what my C prime of 0.5 mean. And what does that result mean? Can you interpret this? What does this mean? So what is C of t? That is the concentration function, right? And what is C prime means? It's something like a rate of change of the concentration. And what we have figured out on that case is the rate of change of the concentration after 0.5. And what is 0.5? It is time, so it is given in hours, right? So if that is the case, what we can say here is after half an hour or 0.5 hours, the concentration of the drugs is actually, because this is positive, the rate of change is positive, so we can say the concentration is increasing, right? And then by what rate? Increasing at a rate of 0.0672. And then if you want to write down the units here, because the drug concentration is milligrams per cubic centimeter, right? So that's what we have, and this is per hour happening, right? So this is the rate of change of the concentration at the 0.5. In the similar way, we can find C prime of 3, and then C prime of 3 is actually, if you follow in the similar way, we need to replace the t on the C prime of t over here by 3, so we get 0.14 times square of 3 plus 0.14. Everything underneath that will be t square plus 1, so t is replaced by 3, so we have then 3 square plus 1, and take a square of that, and then this is approximately equal to negative 0.0112. and then we can use the similar interpretation here. What we can say here is after 3 hours, the concentration of the drug is actually, on this case, because the rate is now actually what you get, C prime of 3 is negative, on that case we can say the concentration is decreasing. But at what rate? At a rate of, the rate is actually 0.0112. We already said that negative we already addressed here by saying that it's decreasing, right? So at a rate of 0.0112, again the same unit, milligram per cubic centimeter per hour. And this is how we can solve this application.